Good day everyone and welcome to our orientation for Chemical Engineering Laboratory 1. Let me formally welcome you to this course. This is CH141L. Let's first answer the question, what is this course about, to give you a brief preview of our course. In this course, we will take a closer look through simulations at the mechanisms behind key concepts on fluid mechanics and machinery, particulate technology, and process heat transfer. So basically, we will be drawing some of your conceptual knowledge from fluid mechanics, heat and mass transfer, and particulate science and technology, and we will be enhancing those knowledge through the use of simulations in lieu of experiments. Okay? What skills or knowledge do we need in this course? First, you need algebraic skill for derivation and solving of working equations. This is a given in any chemical engineering major subject. You need to be able to work on equations. Next, you will also be needing inferential skill for interpreting equations and graphs. Inferential skill is very important whenever you are presented with an experimental data and you are asked to interpret what does the data suggest and what conclusions can you draw from that set of data. You will also be needing your knowledge of fluid mechanics, flow around particles, and heat transfer. Next, let us discuss what are the course outcomes for this course. For the first module, course outcome 1 is to determine the contributions of skin and form friction on the pressure drop of a fluid flowing inside a pipe. Course outcome 2, determine the fluid velocity using obstruction flow meters and characterize the performance of centrifugal pumps. For module 2, course outcome 3, determine the fluidization velocity of a fluidized bed and the pressure drop across a packed bed. And finally, course outcome 4, evaluate the rates of heat transfer in simple tank heating and shell and tube heat exchangers under different conditions. These are the outcomes that we are expecting you to be able to demonstrate at the end of this course. Now let's talk about how will this course be delivered. The discussions and assessments in this course are delivered asynchronously. Asynchronous meaning that you hold your own time and you perform your own tasks and assessments whenever you want, as long as it is within the time frame for each experiment or exercise. The only exemption to this asynchronous delivery are the module exams, which will always be held at specific dates and times at the end of the module. We have two module exams, Module 1 and Module 2 exams, and they are on Week 6 and Week 11 respectively. Now, since our course will be delivered asynchronously, one of the key characteristics that you have to develop or need to possess is self-discipline. That's because self-paced learning requires self-discipline. You are given the power to manage your own time in this course, and you should be able to use that to your own advantage. Next, let us enumerate what are the experiments. We have 8 experiments, 4 experiments for each module. For Module 1, to answer course outcome 1, we have 2 experiments. Experiment 1 and Experiment 2 deals with skin friction and form friction. To answer course outcome 2, we have Experiment 3, flow meters, and Experiment 4, centrifugal pump performance. Next, for Module 2, to answer course outcome 3, we have experiment number 5, flow through packed beds, and experiment number 6, flow through fluidized beds. And lastly, to answer course outcome 4, we have experiment 7, simple stirred tank heater, and experiment 8, shell and tube heat exchanger. Next, we ask, what are the expected assessments in this course? So for this course, we will be doing a little bit of an experiment to see whether we should stick with the traditional lab report assessment or we can do something else. So here's what we're going to do. Half of the experiments, or 4 out of 8 experiments, will be followed by a worksheet where you will be asked certain questions to measure your understanding of the experiment. And the best thing about this assessment is you will not be asked to submit a lab report. Okay? That is for half of the experiments. I will be discussing the details of that later. For the other half of the experiments, or 4/8, will follow the traditional submission of lab reports, and this is an individual task. So with this model, we will be able to compare if you fare better with lab reports, the traditional assessments in laboratory courses, or if you will fare better with a simple worksheet after the experiment. Okay? For those worksheets, we will be following a peer review, which I would discuss later. We also have 2 module exams which will be administered at the end of each module. So we have Module 1 exam and Module 2 exam. What TLAs do we need to expect? TLAs stands for Teaching and Learning Activities, and these are the learning modes that we will be employing in our class. First, we have the guided simulations. Each experiment has its own procedural guide and an online simulator. The procedural guides have already been compiled. They are in a Word document, so you would just have to read the procedure and then perform that in the online simulator. The online simulators are easy to use and are intuitive, so you would have no trouble performing the experiments. Okay? Let's talk about the 4 experiments wherein we will not submit a lab report. You will simply answer questions at the end of the experiment which directly pertains to the theory of the experiment. Instead of long and tedious lab reports, we will be distilling your learnings into a few guide questions that will engage you more. So keep in mind that this is an experimental treatment, so you will be participating in an experiment to determine whether we should replace the traditional lab report submission in laboratory courses. And for these types of worksheets wherein we only have guide questions, we will be doing blind peer reviews. After submitting your answers to the questions, you will be evaluating how some of your classmates answered the same question. We have a separate introduction video to peer review, so after this video, please go to that video so that you will learn more about how can you help in this peer review. Next, let us check our grading table. This is how you will be graded in the course. So we have 8 experiments. Again, 4 of those experiments would require a lab report, and 4 of those experiments would require peer review. If you take a look at this table, all of the assessment tasks that are labeled as paper, that is paper 1, 2, 3, and 4, those are the experiments wherein you will submit a lab report. So that is experiments 1, 3, 5, and 7. For the assessment tasks labeled as worksheet, that is worksheet 1, 2, 3, and 4, these are the experiments wherein there is no lab reports. Instead, we will have a peer review of a few guide questions. Okay? So the peer review is for experiments 2, 4, 6, and 8. And regardless whether you have submitted a lab report or you have performed a peer review, the weights of the outputs of each experiment is always 20% of the module. Okay? For one module, we have 4 experiments. So the 4 experiments is 80% total. And we add to that the module exam, which is 20%. That's a total of 100% for every module. And the minimum average for satisfactory performance or the passing grade is 70%. Basically, the grading in Module 1 is the same in Module 2. Next, how can we reach the instructor? A class group chat will be created in Microsoft Teams, so please visit your account on Microsoft Teams. All questions can be asked through MS Teams either in our class group chat or in a private message. All class announcements will be posted in both MS Teams and Cardinal Edge announcements. And you can message me anytime between 9 a.m. and 5 p.m. every day. That includes weekends. So there will be no excuse for you to say that you are not able to contact me because I am always online in Microsoft Teams and you can reach me during work hours every day, including Saturday and Sunday. If you have any question regarding our course, that could be an academic question or that could be a situational question, don't hesitate to ask me. Just send me a message. And if needed, if you need guidance on a certain topic, we can schedule a voice call wherein we can talk about your problem. Okay? How are you expected to behave in this course? Since we have asynchronous delivery, this grants you flexibility on the time and or date that you choose to work. So with this, I am giving you great power on the management of your time. However, as we all know, great power comes with great responsibility. You must use this to your advantage. Not all of your courses will be delivered asynchronously, so I am suggesting that you make the most out of your time from this course. One of the most important course policies is we do not accept late submissions. You are given a full week for each experiment and worksheet, which would take roughly 60 to 90 minutes to perform, answer, and evaluate. For every meeting, we are hypothetically meeting for 4.5 hours. So that 4.5 hours is plenty of time for you to perform the experiments, do your worksheet, and evaluate your classmates. Another policy that we are enforcing in this course is you must work on your own. You would want to build your reputation as someone who is self-reliant, and I want you to be confident in your answers. In that way, the grades that you will be receiving can be truly called to be your own because those thoughts came from you and they are not influenced by anyone. Next is I want you to evaluate objectively. This pertains to our peer assessments. Remember that the point of the peer review process is critical thinking and enhanced learning. Now, I don't want you to short circuit this process by guessing the grades. By guessing the grades of your classmates, you are performing a great blunder, and I can actually detect if you are simply guessing your grades. So I will be checking all of your peer assessments, and the moment that I see that somebody is not grading properly, there will be sanctions. Okay? So please evaluate objectively. That's it for the introduction. I have covered the important parts of our course. Now for the complete course syllabus, you can take a look at the document uploaded in our class. Okay? Good luck and have fun.